In topic 2, we want to look at writing ratios as simplified fractions. In the previous video, we learned just what is a ratio and we learned how to take words and convert it to a ratio in fraction form. Now we want to talk about simplifying a ratio. So steps for writing ratios as fractions. First, determine the two quantities being compared. So remember, the heart and soul of a ratio is it's a comparison of two quantities. So let's figure out what those quantities are. The first quantity is the numerator. The second quantity is the denominator. And then simplify. And there are different ways we can simplify. Some of these where the two quantities start out as integers, we can just simplify them like we would a regular fraction. But in some cases, our quantities may be given to us as fractions, decimals, or mixed numbers. And those require a little bit, they require some finessing to simplify them. Okay, so let's take a look at some of these. Example 2 says write each ratio as a fraction and then fully simplify. Now, if we fully simplify, we need to understand that for just a basic ratio, we're comparing two quantities, and those quantities are generally the same. When we talk about ratios where quantities are different, we call them something else, okay? So we want to cancel the unit, basically, and then we want to simplify the numbers, okay? So if I have, for like part A, we have $12 to $15, I would write this as $12 over $15, but know that the units, dollars, are going to cancel. We're comparing dollars to dollars. We don't need to include dollar units in each number. Okay. And then 12 and 15 are both divisible by 3. So we want to simplify this just like it was a regular old fraction. Okay. So 12 divided by 3 is 4, and 15 divided by 3 is 5. So yes, we're comparing $12 to $15, but that means for every $4 that we had initially, the second comparison is going to be $5. So for every $4, we have $5, okay? So 12 to $15 or $12 to $15 simplifies to just 4/5. Now, 10 minutes to 2 minutes, we go ahead and write that as a fraction. So um, first quantity in our ratio is the numerator, second quantity is the denominator, and then we want to simplify. And because we're dealing with the same units, minutes and minutes, we don't need to include the actual units with each quantity. We know we're comparing minutes, okay? And then you want to simplify the actual numbers, okay? And what we cannot do, we cannot say this is equal to 5. Okay, our gut tells us, hey, 10 divided by 2 is 5, but when we're dealing with a ratio, we need to maintain the comparison of two quantities. So our simplified or our reduced ratio still needs to have two quantities in it. So what we do instead is we leave this as an improper fraction, okay? So 10 and 2 are both divisible by 2, so we're going to divide both of these by 2. And that tells me that if I'm comparing 10 minutes to 2 minutes, so for example, if it took me 10 minutes to complete a task and it took you 2 minutes to complete a task, that would say that for every 5 minutes I worked, you worked 1 minute. So even though this feels like it should be simplified further, we have to maintain that comparison of two quantities. We have to have a numerator and a denominator. Okay? Next up, we have 2.5 to 1.25. I don't know what we're comparing, but 2.5 of something to 1.25 of something else. So we would put 2.5 in the numerator and 1.25 in the denominator. And we need to find a way to simplify this. So the first thing we would kind of want to do to make this easier for our brains to process is create integers, okay? Integers are not decimals, they're not fractions. So I know that if I can move my decimal twice in 125, that'll give me an integer. And that's essentially the same thing as multiplying by 100. Well, if I multiply by 100 in my denominator, I would have to then multiply by 100 in my numerator, which would move the decimal in the numerator twice. Well, hopefully you kind of remember from our work with fractions, this is really just 1. So we're multiplying this initial ratio by like a weird form of 1. So we're not changing its value. We're just going to make it useful to us. So that's going to make this now 250 compared to 125. Okay? Now 250 and 125, we can reduce that a little bit easier because we know they're both going to be divisible by at least 25. So let's start with 25. Well, for every 100 that we have in 250, we're going to get 4 25s. So we have 200, so that means 25 will go into 200 8 times, and then that 50, 200 will go in it 2 more times. So you can think of it this way, and then I'll show you an easier one. So we would get 10, and then 25 goes into 125 five times, and then here you can see pretty easily that these are both divisible by 5, and we get 2 over 1. Okay, so you can do it like that if you don't see a simpler way to simplify this one. However, some of us might immediately see that 125 is basically half of 250. So 125 will actually go into 250 exactly two times. So we could divide both of these by 125 and we get 2 to 1. And some of you may have been able to see it right here. If you could see that 1.25 goes into 2.5 exactly twice, you could have simplified at this point. Just find a way to simplify it, okay? So you've got a few different options for how to simplify this, be able to support your work, but get it simplified one way or the other. So essentially, we're comparing 2 to 1, okay? And then finally, probably the one that frustrates students the most, just because it has several steps, is comparing 2 and 2/3 to 1 and 13/15. So this would start out as 2 and 2/3 over 1 and 13/15. And what we need to remember is this big fraction bar really just means divide. So we can essentially just take the top number or the first number and divide it by the bottom number or the second number. So I get 2 and 2/3 divided by 1 and 13/15. We know that when we're dealing with mixed numbers and division, we have to convert them to improper fractions. So let's do that. For 2 and 2/3, I take 3 times the whole number 2. That gives me 6. I add the numerator, so 6 plus 2 is 8. And then I keep the 3. And then for 1 and 13/15, I multiply 15 times 1, which is 15. I add 13, which is what, 28? And then I keep the original denominator of 15. Okay? And then to divide fractions, the first fraction stays the same, and I multiply by the reciprocal of the second fraction. And then we can do some canceling and then multiply across. So I happen to know that 3 will divide into itself 1 time and into 15 5 times. Okay? And then I also know that 28 and 8 are both divisible by 4. Okay? So 4 will go into 8 2 times and into 28 7 times. So let's clean this up. We're just going to multiply across. So I get 2 times 5 is 10, and then 1 times 7 is 7. So finally, we have a simplified ratio. When your ratio is simplified, the numerator and denominator will both be integer values, and they will have no common factors. Okay, so 2 and 2/3 compared to 1 and 13/15 is the same as 10 compared to 7. Okay, so that is simplifying your ratios. There are a couple of ways you can approach some of these harder ones like C and D. Just make sure you can justify your work for how you were able to simplify each ratio.